Hello everyone, welcome to our channel Everyday E-Learning. So in today's video of digital logic design, we are going to study Demorgan's law and we are going to simplify some expressions using Demorgan's law or prove those Boolean expressions. Now you see here that Demorgan stated two theorems named Theorem 1 and Theorem 2, and in these theorems Demorgan stated that the complement of a product of variables is equal to the sum of complements of the variable. So it is written here, this one is the Demorgan's law. So this one is basically written like that: a b whole bar is equals to a bar plus b bar. We can also use 3 or 4 variables to indicate the same. For example, we can write a b c d whole bar is equal to a bar plus plus b bar plus c bar plus d bar. So this is the use of Demorgan's law, theorem number 1, as you can see from here. Now let us move on to theorem number 2 explanation. It is said that the complement of a sum of variable is equal to the product of the complements of the variables. So it is written here like that, which we can rewrite as a plus b whole bar is equal to a bar dot b bar. Here it's multiplication and here it's summation. So we can also take multiple variables here for further explanation, 3, 4 or even more number of variables. So we can write it with this example too: a plus b plus c plus d, taking 4 variables whole bar, and this can also be written as a plus b plus c plus d like this. So it can be rewritten or simplified using Demorgan's law as a bar dot b bar dot c bar dot d bar. So I hope you understood this one. Now we are going to apply Demorgan's law in some of the expressions and understand its further applications. So we will take this first example, which we are going to rewrite using Demorgan's law. So we are going to apply Demorgan's law in this equation. So we can rewrite this one using our first theorem, which is here, that is given in the left side. So if we use the first theorem here, we get ab plus c whole bar plus a plus bc whole bar. So again we can use this one to rewrite this line, which will be a b whole bar into c bar plus a bar into bc bar. Then we can again rewrite it as a bar plus b bar into c bar plus a bar into b bar plus c bar. So we just applied the two Demorgan's theorem in this example and rewritten this equation into this form. Now we are going to take another example, which is this one, and we are going to apply Demorgan's theorem to rewrite this expression. So we can first do it like this: a plus b c bar d bar, and apply bar here, and e bar into f double bar. So we applied the second theorem of Demorgan here. Now we can again rewrite it as a plus b bar plus c double bar plus d double bar into, outside we have e bar and f, because if we remember from the basic rules, f double bar is equals to f from this rule. So here we implemented theorem 1 expansion. Now we can again rewrite it as a bar b bar plus c plus d, as the bars cancel out each other. So we have this one, and e bar into f. So this equation looks a bit more simplified from this one using Demorgan's theorem. So we will practice this last example for application of Demorgan's theorem. Now this might look a bit complicated with all these bars over here, but it can be simplified pretty easily. So let me draw a boundary here so that we don't mess it up together. So we can rewrite it as a plus b c bar and double bar here into d into e plus f bar. So we just used theorem 2 for the second line. Now we can rewrite it as a plus bc bar, as these two bars cancel each other, and we have here d bar plus e plus f bar with double bar here. So we can keep this the same as previous one, but we'll make some changes to this one. We can write it as d bar plus e, as bars cancel out for e, plus f bar, as it had one for its own and the remaining two cancel out each other. So we just simplified this one from this equation using Demorgan's law. So this Demorgan's law, along with the basic laws, can be used to simplify complicated Boolean expression. We will practice and see some more simplification in our next video. So don't forget to subscribe and save this playlist for digital logic design. Thank you for watching this video.